Hey, good morning, students.
Good morning, sir.
Good morning. Today
Good morning, sir.
I am going to start with actual vapor compression cycle. So, what is actual vapor compression cycle? So, to understand, first we have done dry expansion VCR cycle or dry compression VCR cycle, wet compression VCR cycle, superheated VCR cycle. Now, today I am going to start this lecture with actual vapor compression cycle. Okay, so what is the difference between theoretical and actual vapor compression cycle? First of all, I will draw this diagram, temperature and entropy diagram. Okay, so from this temperature and entropy diagram, I will explain you the actual working of the vapor compression cycle. So everybody draw this figure with me. First of all, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, and 11 to 1. Okay, everybody draw this figure with me. Look at here. This is called your from 1 to 2. So this is the fact where refrigeration effect will be there. As everybody know, in a theoretical vapor compression, we will take the compression is isentropic or polytropic compression. Okay, but in actual, the compression is not isentropic and polytropic. Okay, first of all, know this that your compression is not isentropic and not polytropic, and in the actual vapor compression, it will also take heat from the and reject heat to the surrounding by the pipe. When it will your refrigerant is flowing through the pipe, then it will also exchange the heat with the surrounding. Okay, and there is also little bit of pressure drop when the refrigerant is passing through the inlet and exhaust valve. Then little bit friction will be there when it will entering inside, then and when it will exhaust from compressor to condenser, then there will be a little bit pressure drop. So first of all, take this point in your mind. Then now I am going to explain the working of this TS actual vapor compression cycle with the help of this TS diagram. So 1 to 2. 1 to 2, refrigeration effect will be there. Refrigeration effect will be there. Okay, when a refrigeration effect will be there, this means when it will take the heat from the refrigerator space, all the refrigerant is converted into vapor. Okay, but in this case, in actual practice, your refrigerant is converted into superheated vapor. So look at here, this is the superheated vapor after compression from 2 to 3. Okay, so when the refrigerant is coming from the evaporator, because it is taking more heat from there, then your refrigerant is totally converted into your superheated vapor. Okay, after this 3 to 4, when this superheated vapor will passing through the pipe and will entering inside the compressor, okay, from evaporator to the compressor, then what will happen? Then little bit friction will be there. Then when little bit friction will be there, then there is a drop in the pressure from 3 to 4. So 3 is your evaporator pressure. PE, evaporator pressure, and this is your suction pressure, P4 to P5, PS. This is your suction pressure. Okay, so when your refrigerant is coming inside, then what will happen? Then there will be a little bit of drop of the pressure. So your pressure will reduce from this evaporator pressure to the suction pressure at 0.4. Okay, and when it is coming inside the cylinder, okay, look at here, because when this vapor refrigerant is coming inside, the temperature of the inside cylinder wall is very high. Okay, when before compression, when the refrigerant is coming in contact with the hot wall of the compressor, then it will somewhat gain the heat from the compressor wall. So look at here, then it will gain the heat from the compressor wall whose temperature is a little bit high from the coming refrigerant, because coming refrigerant is at a low pressure, but the temperature of the inside wall of the compressor is higher than the refrigerant which is coming through the suction wall. So when the refrigerant which is coming inside the compressor, and when it will gain the heat through the wall of the cylinder, then its temperature will get increased from T4 to T5. So look at here. So here the temperature is going to increase. Okay. So look at here from 4 to 5. So it will gain the heat from this cylinder wall at 0.4 to 5. Okay. After this, it will passing, then compression process will be there. Look at here from 5 to 6. 5 to 6 is your compression process in the compressor. When compression process will be there, then what will happen? It's both pressure and temperature will get increased from T5 to T6. Look at here in actual practice. Okay, so here the temperature will get increased, but when it will get compressed, look at here, when the gas compressed in the compressor, whose temperature and pressure will get increased, but the wall temperature is somewhat lower than the compressed refrigerant. Okay, so when the compressed refrigerant is at higher pressure and higher temperature, but the wall temperature is not as high as the compressed refrigerant temperature. Okay, so it will lose some of its heat when it will come into contact with the wall of the compressor. Okay, so its temperature will reduce from T6 to T7 here. Okay, after this, when it will passing through the exhaust valve to the condenser, then again pressure drop will be there. Then again pressure drop from 7 to 8 will be there. So this is the pressure of the condenser PC. This is the pressure of the condenser, and this is the pressure of the discharge valve through the discharge. Okay, PD. So I have denoted PD pressure at the discharge, and PC pressure at the in the condenser. Okay, so then 7 to 8 there will be little bit pressure drop from discharge pressure to the condenser pressure. Okay, so when it will entering into the condenser, okay, when it will passing through the after discharge valve, what will happen when it will passing through the your pipe to the condenser, and when it will entering to the condenser, then first it will removing it superheating heat to the surrounding, superheating heat or temperature to the surrounding. When it will lose its superheating temperature, first it will lose its superheating temperature from 8 to 9. Look at here in this figure. Okay. Then from 9 to 8. Look at here. Through when your refrigerant is passing through the condenser, condensation will be there. Then it will lose its latent heat. When the refrigerant is losing its latent heat, then there will be a phase change. When there will be a phase change, then the vapor refrigerant is converted into liquid. So look at here, this is your saturated liquid line on which every refrigerant in vapor form. But through this is your condensation process. This is your condensation process through which when your refrigerant will flow, then there will be a phase change in this process. Phase change after removing the latent heat. When it will remove its latent heat, then there will be a phase change. Then your refrigerant will convert it into from this vapor to liquid state at point 10. So all your refrigerant, this is your saturated liquid line. This is your saturated vapor line. So look at here. On this line, all your refrigerant is converted into your liquid form. Okay, so there will be a phase change from 9 to 10 in this process. Okay, so after this, from 10 to 11, so look at here, subcooling is there. Subcooling is there. When subcooling is there, this means from 10 to 11, subcooling is there. And your refrigerant again going to subcool after condensation. Okay, when it is going to subcool from 10 to 11, look at here. Then again this subcooled refrigerant passing through the expansion wall. So look at here. This is the expansion process from 11 to 1. From 11 to 1. Expansion process will be there. And everybody know when expansion process will be there, then throttling of your refrigerant will be there. Then what will happen? Both the pressure and temperature will get decreased. Okay. When both the pressure and temperature will get decreased, then it will again entering into the refrigerating space, into the evaporator, from where it will again take the heat. So again this cycle is there. So this is the actual vapor compression cycle. So it is a little bit different from the theoretical vapor compression cycle. So everybody note on this diagram, because I am going to put MCQ type question from this diagram. Okay, so everybody must draw this diagram and put everything, write everything on this diagram. Hurry up, everybody. I'm giving you 2 minutes time. Everybody draw this figure, hurry up. Now I'm going to erase it. Now next question will arise. What will be the effect of the suction pressure? If I will reduce the suction pressure, then what will be the effect of the if I will reduce the suction pressure, then what will be its effect on the coefficient of the performance of the system? Okay, on the so first of all, everybody draw this figure. Effect of the suction pressure. So what will be the effect of suction pressure? So this is your temperature and entropy diagram. Wait for 1 minute. So now beta, look at here. What will be the effect of suction pressure? So first of all, everybody draw this TS diagram. So look at here. From 1 to 2, refrigeration effect will be there in evaporation, and 2 to 3. 2 to 3, this is the process of compression. Okay. And 3 to 4, this is the process of condensation from 3 to 4. And 4 to 1, this is the process of expansion process. So what if I will reduce this? What will happen if I will reduce this suction pressure? So what will happen? Suction pressure. What if I will reduce this suction pressure? If I will reduce this suction pressure, look at here. This is your suction pressure at point 2. At point 2, this is your suction pressure. If what if I will reduce this suction pressure from 2 to 2 dash? Look at here in this figure. Okay. Then compression will be from 2 to this 2 dash to somewhat on this point 3 dash. This will be your compression process on temperature entropy diagram. Okay, so this will be your compression process after when your suction pressure get reduced from 2 dash to 3 dash is your compression process when your suction pressure will get reduced. Okay, so look at here. Your again, this will be your entropy. Both have same S1 will be equal to S4. So look at here. This is your point S2. This will be your point S2 dash, entropy at 2 dash. And after compression, this will be the entropy S3. And this is the entropy of the reduced when your suction pressure will get reduced. So after compression, the point 3 dash will be exist. So first of all, for theoretical vapor compression, first it's COP. What is COP? Refrigeration effect divided by work done by the compressor. So what will be the refrigeration effect of theoretical vapor compression before reducing the suction pressure? Okay, then it was H2 minus H1. This was the refrigeration effect was there. Okay, divided by work done. So work done is H3 minus H2. So this was the coefficient of performance. Okay.
सर आप म्यूट हो सर. हेलो सर. हेलो सर, म्यूट हो आप सर.
So look at here. This is the actual COP of this theoretical cycle before compression. But look at here. What if I will reduce this suction pressure? Then what will happen? If I will reduce the suction pressure, okay, so this your point one will somewhat come here, 1 dash. Okay, first the refrigeration effect. This was the refrigeration effect before reducing the suction pressure. This refrigeration effect was there. But after reducing, look at here, this is the refrigeration effect. So this means this much refrigeration effect will get reduced. This much refrigeration effect will get reduced. So what its effect on the coefficient of performance of the cycle? So look at here, your compressor work will get increased from 2 dash to 3 dash. In this case, your compressor work will get increased from H3 dash minus H2 dash, and your refrigeration effect will get reduced here. How much reduced? Look at here, H2 dash minus H1 dash. Okay, so this means what will its affect? The overall COP of the cycle will get reduced. If your section pressure will get reduced, then the COP of the system will also get reduced. So this will be the fact on the COP. Your COP will get reduced. So everybody note on it. Hurry up. Now next, I am going to draw the TS diagram. What will be the effect of discharge pressure? What if I will increase the discharge pressure? So everybody draw this diagram for discharge pressure. From 1 to 2, evaporation process will be there. 2 to 3, compression process. 3 to 4 again, condenser process, and 4 to 1 is your expansion process. Okay, so everybody note on it. What if I will increase the discharge pressure? Then what will be the effect of this discharge pressure on the COP of this cycle? So everybody note on it. If I will increase the discharge pressure from 3 to 3 dash, okay, and what its effect on the COP? So look at here. Again, I am going to complete this cycle. After this discharge pressure, if I will increase discharge pressure from 3 to 3 dash, okay, then this will be the point after condensation, okay, and after condensation, this process 4 dash to 1 dash, this will be your expansion process. Look at here from the figure, this will be your expansion process. So first of all, the refrigeration effect was before increasing the discharge pressure. So this was the refrigeration effect was there. Okay, but when I have increased the discharge pressure, then what effect on this cycle? Then your refrigeration, look at here, refrigeration effect will get reduced. In this case, how much reduce? This much reduce, X. So your refrigeration effect will get reduced in this case. Okay, and the compressor work will get increased. Again, the COP of the system, that will be refrigeration effect divided by work done by the compressor. So in theoretical cycle, first it was H3 minus H2 before increasing the discharge pressure divided by work done H2 minus H1. This was the COP. Okay, but after increasing the discharge pressure, then increasing discharge pressure, then your refrigeration effect will decrease from H2 minus H1 dash. H2 minus H1. Your compressor work, that will be also increased from H3 dash to H2. Okay. So your COP also, this means your compressor work will get increased here. Look at it. In this case, your compressor work will get increased from H2 to H3 dash. Okay. And your refrigeration effect from this figure will get reduced. So what will be the effect on the COP? Your COP will get decreased. So this will be the effect if I will increase the discharge pressure from the compressor. Okay. So note on it, hurry up. Next is your, what will be the effect of subcooling on your refrigeration cycle? Now I am going to raise it. Again, draw the TS diagram. Temperature and entropy diagram. So what will be the effect of subcooling? So first of all, I will, what will be the effect of superheating? So two processes remaining, superheating and subcooling. So what if your vapor, which is coming from the vapor in superheated state, in superheated stage from 2 to 2 dash, look at here, then your compressor work will be 2 dash to 3 dash. First it was from 2 to 3, but when your vapor is coming superheated stage, so this means after evaporation, its pressure, its temperature will get up to this 2 dash in superheated stage. Okay, so look at here. After compression, its pressure and temperature will get increased from 3 dash. First it was 2 to 3. Okay, so this means 3 to 4. This will be your condensation process. 4 to 1 expansion process, and 1 to 2 evaporation process is there, and 2 to 3 your compression process. So what will be its effect on the COP of the cycle? Refrigeration effect. divided by work done by the compressor. First, so in this case, look at here. Your first it was H3 minus H2 divided by work done. Refrigeration fact H2 minus H1. Compressor work H3 minus H2. But when your refrigerant in superheated state after evaporation, then what will it expect? Look at here. Your compressor work will get increased from H3 dash to H2 dash, and your refrigeration effect will also increase. Look at here. From H2 dash to H1, refrigeration effect will get increased. But this refrigeration effect will get increased on account of increase in the your compressor work. Compressor work is also increased because it has to work on higher pressure and temperature because it has to compress superheated vapor. Okay, that's mean your compressor work also get increased in this case, and refrigeration effect will also get increased. Okay, so this refrigeration effect will increase on account of higher work done by your compressor. So the work done by the compressor is get increased. So overall, if your work done of the compressor will get increased, so the overall COP will get again reduced. So this will be the fact if your vapor is coming after evaporation in superheated state. Okay, so this will be the fact on the superheated after evaporation. So everybody note on it. Hurry up.
सॉरी फिर से बता दीजिए सर हेलो
Better look at here. In this case, your vapor in superheated state. So when your vapor in superheated state, what will happen? Its refrigeration effect will get increased from 2 to 2 dash. So look at here. This much refrigeration effect will get increased. Okay. But this much refrigeration effect will get increased on account of this compressor work. This compressor work is also increased from H3 dash. First it was the compressor work was H3 minus H2. Okay, but after when it will compress the superheated vapor, then compressor work is also increased from H3 dash to H2 dash. Okay, so refrigeration effect will get increased on account of this increased in the work done by the compressor. So when work done by the compressor is get increased, the overall efficiency COP, coefficient of performance of the cycle will get reduced. Okay, so this will be the fact when your refrigerant is in superheated state after evaporation process. So this will be the fact. Note on it. Hurry up. Now I am going to raise it. Next is what will be the effect of subcooling? Effect of subcooling. What will be the effect of subcooling? First of all, for this TS diagram, temperature and entropy diagram. Look at here. 1 to 2 evaporation process will be there. 2 to 3 your compression process is there. 3 to 4 your condensation process is there. And 4 to 1 your expansion process is there. So look at here. This is the your COP of your practical COP of the refrigeration cycle. Okay. So what if I will get reduced subcooling the refrigerant in the condenser? What its effect on the COP? If I will reduce the temperature, if I will reduce, look at here, subcooled, this is your subcooled region. Subcooled region. And this is your superheated region. When I will subcool it from 4 to 4 dash, if I will subcool it, then what will its effect on the COP of the system? So look at here. If I will subcool it, then first refrigeration effect was refrigeration effect divided by work done of your compressor. So first refrigeration effect was H2 minus H1 and work done by compressor H3 minus H2. But when I subcooled the refrigerant after passing through the condenser, then this much refrigeration effect will get increased from 1 to 1 dash. So your refrigeration effect will get increased from 1 to 1 dash. This means your refrigeration effect will get increased from H2 to H1. Okay. And your work done by the compressor. Work done by the compressor is remain the same, H3 minus H2. So what will its effect? Look at here. Refrigeration effect in this case will get increased on account of same amount of your work done by the compressor. So what will its effect? Its effect will be the COP of the system only in this case will get increased. The COP of the system will get increased. Okay. So this will be the effect. So this will be the effect. So everybody note on it. This is your pressure enthalpy diagram. Pressure enthalpy. This is your pressure enthalpy diagram, not TS. Everybody note on it. This is your pressure enthalpy diagram. Because I am writing enthalpy, so this is your pressure enthalpy diagram. So look at here. In previous figure, you can also correct this Ts replace with pH. Okay. So this is your pressure enthalpy diagram. So this will be your enthalpy at point 3. This will be your enthalpy at point 2, and this will be your enthalpy because of both this enthalpy H1 is equal to HF3. But in this case, this will increase from H4 dash to H1. So both are same. Okay. So everybody note down this. This is your pressure enthalpy diagram. So this will be the effect on the COP of the system. Note temperature. Everybody, please correct it. Okay. So in this case, the COP of the system will get increased. COP of the system will get increased. Now, beta, I am going to share with you the poll. The very first poll I am going to release over here. First of all, everybody note on this diagram and what will you expect on the COP. Okay, this is very important question for paper point of view. Mostly it will come in the paper more than 5 marks. Okay. What will be the effect of on the COP of the subcooling, superheating? If what if the discharge pressure will get increased? What if the suction pressure will get a decrease? What will its effect on the COP of the cycle? Okay. So this is very important question. So the pH diagram for the 4 processes. Everybody note on pressure enthalpy of your suction pressure. What if suction pressure will get reduced? First it was there 1, 2, 3, 4. What if I will reduce suction pressure? Then it's a refrigeration factor will get reduced. Okay, so this will be H3, H2, H2 dash. This is your 2 dash. H1 is equal to H4. If your suction pressure will get reduced. First case was there. Second, pH diagram. When your discharge pressure will get increased. First case was there. When the discharge pressure will get increased, then what its effect? Okay. So this means this much your refrigeration effect was going to decrease. Okay. So the overall COP will get reduced. Then one more case was there. Pressure enthalpy diagram. When your vapor after evaporation in superheated stage. Okay. This much refrigeration factor will get increased, but on account of your increase in the work done by your compressor. Okay, so overall your COP will get reduced in this case. So everybody, you have drawn this diagram on pressure enthalpy diagram, and you have seen that only in case of subcooling your COP will get increased only in one case, and remaining all the three cases your COP will get decreased. Okay. So this is all about what will be the effect of suction pressure, discharge pressure, superheating, and subcooling on your COP refrigeration cycle, VCR cycle. Okay. Now, beta, I am going to release the very first poll. Everybody should have to answer it. So, first of all, open your very first diagram of actual vapor compression cycle. From that diagram, so what will the process of 3 to 4 represent? Actual vapor compression. See from there. So what does process 3, 4 represent?